Good day, everybody. So today I'm driving to a new place in the desert to, begin my next adventure. And during my packing, I was listening to this book called Existential Physics by Sabine Hossenfelder. I think that's her name. And so, yeah, we're going to talk about the beginning of the book. I don't know how many chapters in I am, but a few things here we've got that stuck out to me, where her discussion of like cosmology and some of the theories in cosmology, and how she's like, they don't explain anything because they can explain everything, so they're not falsifiable. And let's see, what was the other thing that I really wanted to get into? Well, I guess, yeah, let's just start there. We'll see where we get. So yeah, one of the examples she uses is with the inflationary model of the expansion of the early universe. And she's like, so this is one of those ideas that we have that a lot of physicists, kind of accept. But it doesn't actually explain much, because if you imagine starting, basically if you imagine whatever kind of data that we might get in the future, she says that it would be possible to basically fudge the inflationary model parameters to match it. And so there's no way you could falsify it. And so she does this with quite a few different pet theories, maybe, in physics. And, part of me is like, yes. I mean, I enjoy that. I enjoy a good battle. A good mental battle in the physics community is always great. But I do want to point out, and maybe it is apparent to her, but she does talk about the, what do you call it? Basically the current accepted theory of the universe, which is heavily based on general relativity, and basically this idea of the expansion of the universe as it comes from the cosmological constant in Einstein's original paper, or the original equation, before he tried to remove the cosmological constant. So I would just say that theory also has been adjusted over time. I mean, Einstein originally removed that because he didn't think it was elegant to have a cosmological constant, and then when Hubble found that the distant galaxies were receding and redshifted, then he was like, crap, my greatest blunder. So I don't know, I feel like the same thing kind of applies to that, where the theory kind of has been adjusted over time to match observation. And so if you're basically saying things that can be adjusted to match observation shouldn't be, accepted, or, valued like they are, then I don't know, I think it kind of applies to the same theory that she is accepting, I guess, or basically to most theories in science. Now, of course, I mean, I do agree with her that ideally you want a falsifiable theory. But I think maybe she's just a little pessimistic as far as the psychology of scientists goes, to think that inflation or something, let's say, is just infinitely going to be fudged to match the data, because I don't think that's really how most scientists would think. Like, yes, if you can fudge the numbers and, you know, adjust things and make it fit the new data, then okay, why not, I guess. But at some point, like, if somebody comes up with a better solution, then I think that that's going to be adopted. It's not like it's just going to be like in religion or whatever, where it's like, no matter what happens, no matter what you discover, you believe in the same God for millennia, right? You just continue to just evolve that idea and say it's the same God even though it's not. I think at some point you'd be like, this is not inflation anymore. Like, this is a new theory, right? You wouldn't be like, this is, you know, Yahweh in inflationary form. So I think that that's, I don't know. I don't really see her argument as being like, I mean, I find it interesting and I like it, definitely, but yeah. All right. Okay, I just remembered. I had to pause you to to remember what it was. So she also talks about Max Tegmark's mathematical universe. He's written some good books too. You should check him out. But basically, his idea is like all of mathematics exists, and you know, our current universe is just kind of a certain set of mathematics, right? Although it is interesting that, I mean, I don't know. He's saying that the set of mathematics that we can discover in our universe is larger than the set of mathematics that is necessary for our universe to exist. I think that would be interesting. But anyway, Sabine basically says, like, I find this a bit presumptuous to think that, basically in the 2,000 years, 6,000 years of human history that we've really developed thought, philosophy, that we've already come across like the right theory of the universe. Like, we've already been like, this is the best way that you can explain the universe. And, you know, we just happened to stumble on it. And this idea of just everything exists as mathematics is the solution. She kind of throws some shade on that and just like, nah, I don't know about that. And I do like, I mean, I definitely like that attitude of just, yeah, let's hold your horses a little bit here. But at the same time, I do think that there's something to mathematics as, I'm definitely not saying like it's a universal solution, but I feel like mathematics can almost be mapped onto any better way of seeing the world, even if it's not like a very elegant way to do it. Like, you can find a function to approximate whatever you want, right? So like, I don't know. Like, mathematics is like still an ongoing thing. Like, we're still discovering new mathematics and new ways of like doing it. So if you want to say like current mathematics is like, our current understanding is everything, then I would be like, yeah, no. But like, the principle of mathematics, I feel like it's kind of like the same as like the principle of science, of just empirical evidence tested against theory, and finding the best theory that can predict basically future observations. Like, that principle of science, we're trusting to carry us forward in the future. And I think, I mean, yeah, we might come up with a new, better way of doing science in the future, but I think ultimately it has to like encompass at least what current science does, you know? It has to make predictions, right? That are true, right? So, I don't know. It's hard to imagine any sort of future idea, future scientific method that takes over the scientific method that doesn't include that. Just like I would say, like, if we had some other explanation of the universe other than mathematics, like the principles of mathematics, going like the way that mathematics has developed is just like the stepping stone of being like, what axioms do you need to do the most with? And then just kind of adjusting those to see what you can do, and then being like, do we need to introduce a new axiom here? Or can we derive it from other ones? And if we can't, and it's really important, should we create a new axiom? And just, building this edifice. And then you can even consider all the different edifices you could build with all the different axioms and take the complete set of those. And then, like, all of that could be considered under the umbrella of, like, the mathematical method. Just like I think any future scientific method would be kind of under the umbrella, have to satisfy many of the same things that the current scientific method satisfies. So, interesting stuff. I do enjoy her book so far, and I will keep you posted on the rest of it. I've only just begun. It's quite good. Anyway, I will talk to you later.